Hi, welcome back. So today we are working on a LENNOX package rooftop unit. Actually, this is a maintenance, and I just wanna show you something. And this roof is filled with the water all around the unit. I tried to make a way to get the water out of the roof, but it's going very slow. Anyway, let's jump the unit to the cool mode. Okay, so I have jumped between R and Y1. Let's turn on the power. It's all around water. Okay, so the blower motor is on. I think it has some kind of delay. Let's wait for it. Okay, so after jumping out between R to Y1, unit was not, like a compressor was not turning on because the ambient temperature is low today, and I did not have any, like a bypass, to bypass economizer section plug. Usually I have in my bag, but today I don't have. So the compressor is not turning on because it's opening the economizer section. But the funny thing is that unit doesn't have the canopy for economizer. But inside it has economizer, actuator and everything. So the damper were opening for the free cooling as the ambient temperature is low, but the compressor is not kicking on. So our main issue with the condenser fan. So what we're gonna do, we're gonna uh, give the power to condenser fan relay, like 24 volt. So then we first have to locate the relay. Okay, so in the electrical section we have three contactor, two for the compressor, one for the main blower motor, and we have two relays. One should be for exhaust fan for the heating the venter motor. The second one should be for the condenser fan. As we know, we have two condenser fan here, and this should be the relay for condenser fan. So this is the 24 volt, this is the common to activate the relay, and these two wire are going for the condenser fan motor. As the relay activates, these two wire get contacted inside the relay and turn on the fan. But we have to confirm from our wiring diagram. So just check the LENNOX, they usually provide the number on their wiring. So as we can see here, it says K13. If you can see K13, that's for the, which I suspect is a venter motor. Let's confirm with our wiring. Okay, here is our schematic. So K13, it says relay combustion air inducer. So the other relay gonna be for the condenser fan motor. On the wiring diagram, let's check our condenser fan, where the condenser fan is located. So this is the line 1, line 2, line 3 high voltage side, B1, B2 with the HR1, HR2, these are the compressors. B3 is in the blower motor for the fan, and B4 and B5 should be the condenser fan motor. Just confirmation. Motor outdoor fan 1, 2. So these are our condenser fan motor, and here is K10. Just confirm with our list. Where is K10? Yeah, here. Relay outdoor fan. So outdoor fan means condenser fan motor. So K10. So we have to find out K10. The other relays most surely is for condenser fan motor. Okay, so this is the relay for the condenser fan motor we have confirmed, and this is the proof. It says on the wire K10, and in the list we have confirmed this is K10. And so we have to activate this relay to turn on the condenser fan. So this is the 24 supply, and this is the common. Gray is the common. Just remove this one, and my other section is my other jumper and is connected to R, and now we are connecting it here. So once we turn on the disconnect switch, the 24 volt supply will go to this relay, and the condenser fan should turn on. Okay, let's turn on. It's all wet here. This motor is making a very loud noise, so that was the cause for our today's troubleshoot. Not a troubleshoot, actually I was doing the maintenance and I found out this motor is making a loud noise. So we recommended customers to replace it, and we're gonna replace it today. So we have located the relay, we bypassed the relay. Of course, whatever you do, the thing like this, always remove the R wire, the thermostat wire from the PCB from here. So I already disconnected it. Otherwise you're gonna short the thermostat and it's gonna blow up. Okay, so this is our motor making a loud noise. See, it's partially seized. Yeah, the bearing is gone. So it's a matter of time, it's gonna stop working. So that's the main motive to do the maintenance on this unit. So you have to find out the trouble which can be disaster for the unit in future, so that the customer will not suffer. Okay, so this unit is 2006, still working fine, but we have to confirm the voltage before we replace the motor. Always make sure, because the supplier has supplied me the wrong voltage motor many times. So after that I am making sure before installing and before picking up the motor it's the right one. So this unit is 575 volt, and this is our outdoor fan, single phase. So single phase, and there's no mention of voltage, that means it's 575. So 575 single phase outdoor fan motor. Okay, so this is our new motor. I'm just checking the spec here, and everything looking okay. 575 volt, 1/3 HP, and everything is as per the spec. Of course, every time we replace the motor we should replace the capacitor. 7.5 microfarad. These are the capacitor for the outdoor fan. So one should be for our motor, which we are replacing today. So disconnect switch is off, but we are working on electrical side. Even if the disconnect switch is off, so we have to make sure with our multimeter the unit is not live. Put the meter into the voltage. L1 L2 0, sorry 3, L1 L2 0, L2 L3. So looks like we are okay, no voltage, and we have to confirm that every phase to ground should be 0. Okay, so This is the old motor. We're gonna use this rain cap, and this is our new motor. The shaft is a little bit longer because this is not the OEM. LENNOX supplier did not have the parts in the stock, so we had to order it like aftermarkets, but this is a very good brand. And we also have to cut the shaft. The shaft length is like, this is too big. And the main thing is, so the shaft is gonna be towards the upward direction, so this is the port we have to let it open, and this side port should be closed. So that's the main thing to keep in mind. Okay, so I have installed that new motor. I already cut the shaft to the length, installed the rain cap, and difference is this motor is having 4 wire, 2 wire for the capacitor, and 2 line 1 line 2. But the OEM motor has only 3 wires, and the capacitor is connected here. This is for the other fan, and I removed the capacitor. So this is how it is connected. So 1 wire from the relay, red wire, yellow wire, and the purple wire. So 3 wire going to the fan motor, which is the original one, but which for the new motor I have installed, I have removed the capacitor here. Yellow wire is going directly, as you can see, 2 wires to the same terminal. Yellow wire is going to directly, but the orange wire is not usable because I had capped this orange wire here. And if you can see, the orange wire I have capped here, and 2 wire line 1 line 2, red and yellow, which I have connected with the motor. And here I have installed the capacitor, which is perfectly, is gonna be in the shade. I have taped it up properly. Everything is fine. Before installing the fan blade, I just want to make sure the rotation, and this motor has the provision of both direction rotation. Just we have to flip it, this connector here, remove and flip it. So before making sure everything is okay, before installing the fan blade right there, just I want to test it. And let's turn on the power. The relay is bypassed. That vibration is coming from this panel. So motor is working fine. The other fan motor is good. The new one is okay. Okay, I have taped up all the wires, properly connected. Capacitor is in the rain protection, and everything is nice and tight. Fan blade is in. It's not touching anywhere to the body. Let's give it a try. Okay, it's working nice. That noise is coming from the rain cap. I think it will settle. No vibration, everything is looking okay. Okay, so I have properly placed that rain cap all the way to the down, and let's check now. Yeah, it's looking fine. Okay, thank you for watching. Please subscribe.